it was taught by, I shall not reveal his name, and he was the most boring lecturer on campus, I'm sure. He put people in comas. And he was very fastidious, and he used to lock these doors. The door is behind this drywall, and this door, and if you came late, he'd just not let you in. And I'm not sure what he did when you incessantly knocked on the window, but about that. If encourage you to come late, just walk in here, and it's going to be hotter and hotter. Shorts, but we have a kind of like departmental evaluation this week, so I don't want to create the wrong impression. I don't know what impression I do want to create, but it's okay if you come late. As it happens, I'm going to leave the door open just in case it gets a little hot, because I'm already feeling a little hot myself. Now, I was a little panicky because I realized that I was never ever going to get through all the material until I lay in my bed and decided that we were the last chapter about modeling the World Wide Web is fascinating stuff, but we just won't get to it, and there are other more important things that you must know about this tail end of computer science. So now we are a little more relaxed, and I'm going to take today to finish up stacks and queues again. I think this is the third attempt. But just before then, we did look at this on Friday, so I don't have to repeat the stuff about the practical test. I haven't remarked it yet. I'm a little scared. It's to make sure that if I press remark, if I change the penalty and press remark, which I can do somewhere, that it won't delete all your, I don't know what, another opportunity to write about. First, I have to make sure that I won't break anything by 50% penalty for each try will be removed or repaired. Two people sent me an email saying that they handed in late or they forgot to submit, and I'm really sorry about that, but there was the practice session week before, and you have, I mean, you're not stupid people, so I'm not going to accept these late. It's like coming our day after an exam and saying, I forgot to hand in this one sheet of my answer paper, which you still accept and mark it. So I'm not going to do that. What I am going to do is to, just give me a second. In my mind a second ago. Oh, well, that's gone. We shall never know. Oh, YouTube. One thing I haven't done, which is really bad, is to add the YouTube links to the schedule. But I'm recording on YouTube today, am I? Yes, I am. And if we go to our schedule, okay, let's go here. Oh no, man! Why? This is not the first time it has happened to me. I don't know what's wrong with this computer. Don't panic, I think it takes a third time. Okay, now you can panic. Okay. Oh. Okay, I don't know. It may be the internet, but I'll put up the links to the YouTube. Right here. So let's talk about Kevin. Now let's talk about the work. There's two small things that we need to talk about. One is called iterable collections. So when we started chapter 4, what did you start with? What's 4.1? How can your memories be so short? You spent weeks and weeks on it. So 4.1 is about performance. You need to know the performance of, so maybe you want to, Oh, yeah. Wow. Okay. It's about the performance of algorithms and programs. We need to know about that. 4.2 is about searching and sorting. So that's fine. Performance is like general for all algorithms. Searching and sorting are very specific classes of algorithms. And there are many ways to search. I can do a linear search, or I can do a binary search. I can do something called a hash table, which we'll get to next lecture. There are many fancy ways for searching, and searching is massively important. You think that searching is so stupid, but it's very, very important. For example, I mean, Google, how do they search? How do they search billions and billions of internet pages? So for them, searching is critical. That's a business. Searching is also important in biology. So you have much more information on the internet inside every little cell. Let's find a cell, someone's cell. The code can happen with your head. So you know that each of your cells is it's humongous, it's petabytes of data. Biological researchers, people that do bioinformatics, want to search through that for patterns. How do they search for those patterns? Well, that's why searching is important. Am I correct in saying that you just did searching for one string inside another string? One person thinks I am correct, I'll just assume I am. And what we really want to do is search for one pattern inside a different pattern. So I want to say something like, I'm looking for A, B, blank something, C, D inside a very long string. And when you start adding that complication, that you can have blanks or wildcards, funny characters, regular expressions, then searching becomes a lot more complicated. Sorting, also important because computers do that all the time. They're always sorting the whole time. And for different situations, you need different sorts, and it's exciting to learn about the sorts. But those, that's it. Searching and sorting is a class of algorithms. What you're going to be doing next year, and what we're doing now, is a different part of advanced computer science called data structures. Now, data structures and algorithms go together because depending on the data structure, you use a different kind of algorithm. But data structures are really important. For all these things, performance is also important. If we talk about data structures, what are we talking about? Basically, I've got some pieces of data and I want to add them to some collection. So I need generically, I need some kind of adding and I need some kind of retrieval. It may be removal, or it might just be a lookup. I want to take it out, like a telephone book. When you look in a telephone book, you don't cut out the name every time you look at it. So it may just be retrieval. And sometimes I want to make a list of everything inside my collection. I want to go through the collection item by data item. And that is what these iterables are about. So if you have a collection of data, so this is called a collection, and you want to iterate over all the data items in that collection. How do we do that? Well, usually it depends on the data. So you write some code if you go through that data somehow next until the end. If you have more complicated data structures, the kinds that we won't be looking at in this course, like trees, where every node, it's like a linked list, but instead of just one next, you actually have two next that go to two subtrees. And now you have subtrees, and now you have subtrees all the way down. And these are just plain data structures that get much more exciting. But if you have a tree, then your iteration will be very, very different from a list or an arrow. So do you have to write specific code to cater for the specific data structure that you're using at the moment? That would be wasteful because you'd spend all your time just writing iterators. So what Java has done, and many other languages, but Java also, is to find some kind of framework where you can say, here is the definition of my data structure, and I'm going to tell you how to iterate over it, so that if you're a client and you're using this data structure, you don't have to know what kind it is and how to walk through this data structure. I'll provide the iteration for you. So you tell me you want to iterate. I say, okay, I will iterate for you, and for each data item, I'll send it back to you, and you can do with that what you want. So if you just have an array, I'll write the for loop, and for each data item, I tell you, there's a data item, there's a data item, there's a data item. Okay, right. So let's have a look at this little piece of code. Let's just see what it says. It says, I have a stack of string. So remember, this is a parameterized class. Stack is a class, actually it's interface, and it takes a parameter by term. That's the kind of data I want to store in the stack. So I don't have separate stacks for separate data. I just have one stack interface, and it takes a type, in this case string. So it's going to be a stack of strings. And I call that my collection. It's a variable called collection. So collection is going to point to something that's a stack, and it obeys the stack interface, which is a contract between me and whatever implementation it is. I don't know how it's implemented. I don't want to know. All I know is that collection is pointing to this kind of stack. And here it says collection is equal to a new stack of string, bracket, bracket. So this is actually calling the constructor for the stack class parameterized with a string. Now, this is where my little speech breaks down, because in this piece of code, they said new stack of string. And if stack is an interface, you cannot say that. You can't make a new stack. Stack is just an interface. It's just a contract. It doesn't implement a stack by itself. We need to pick some kind of implementation, like an array stack, and we auto-write new array stack of string. Stack is an interface, and interfaces can't be instantiated. Have you heard that word? You know the word instantiate? I instantiate you. It's fine, I instantiate you. Okay? No, it's when we have a class and we create one instance of a class. We can't instantiate interfaces because they don't have any body, they don't have code in them. They're only specifically available. So this ought to be array stack of string, or linked list stack of string, or linked list stack string. But let's just forgive the textbook for now. So I've got a collection, it's some kind of implementation of a stack of string. And then I can say things like for, ooh, now have you done this stuff? I'm pretty sure we did it in the first semester, but just can't recall. I mean, it's all the drugs, it's just black. I don't even recall teaching this stuff. Okay, so you know Java's for loops. You all know the usual for loop where you say for int I equals 0, I less than 10, I. But this is a different kind of for loop. In fact, it has a different name. It's called for each statement. And in other languages like Python, who knows Python? Let's call it 6 people. In Python, it's not even called, no, Python is also called for. It's 4. Is it? For x in range. Yeah, it's called 4. But different languages like, give me a second, I can do this, I can do this, I can do this. PHP, who knows PHP? The language of the web. Oh, fewer people. Oh. What did? Did you call me a SETI?
No, I said Satan.
Satan? No, PHP is fine. PHP is fun. It's a little hunky-dory, but PHP has a separate for each keyword. So I wouldn't write this in PHP, I'd write for each. Never mind that. In Java, it's also for, which is a little confusing, but the notation is different. What you say is for string s, so just like before we had int I, but then you don't write equals 0 or what have you. You say colon, and some variable that is a collection of string. If I had, instead of string, if I had int up here, integer, capital integer, Java would say, you can't write this. You can't write string s colon collection, because collection is a collection stack of string, of integer, and you can't pick up string s's out of this collection. So this string that's in the start of the for loop has to agree with I can print it out to the standard output. And this will, I promise you, this will work. How does it work? I mean, we want to go deeper. We want to see the connection on what goes on the inside. How does Java know this string must be the same as that string? Well, actually, I'm lying to you. It doesn't have to be the same. And this string is the same type. It actually checks something else. It checks that collection, which is a stack of items, it checks that collection as one very specific method. And that method needs to be called iterable. Iterable. I'll check. All right. Right, so iterable. And what that means is that I can iterate over this class. So inside collections, there must be a method called iter. Just give me a second. I've got to get this right because it's tricky. Okay, so here we go. There must be a method called iterator. And therefore the class stack must implement this interface iterable. So my stack at the moment doesn't do that. Do you remember my stack? It's like MySpace, but cooler. No, my stack. Let's just see my stack. Stacks is source stacks. Let's call it our stack. There is our stack interface. There's nothing in this interface that says it will satisfy the iterable contract. And therefore, I cannot iterate over this kind of stack. What is that? Stack of? That's stack of strings. Okay, so I'm going to use this. I'm going to use the stack of strings interface. I'm going to go to my test program. I'm going to push a load of stuff onto the stack. That's still fine. And I'm going to write this new code that I've learned. For string s in stack, print s. Okay, and Java compliance, Eclipse compliance, but it's actually Java. And the problem is that you can only iterate over an array or an instance of java.lang iterable. Stack doesn't provide that method, iterator, so I can't iterate over it. And the way to fix that is to say that, okay, now it's going to get a little tricky, but you'll survive. This is an interface. If this were a class, it could extend one other class, it becomes a subclass, or it could implement or it could implement a lot of interfaces. So a class can extend one class, and it can implement other interfaces. But an interface can't implement different interfaces. It doesn't implement anything. So when we're dealing with a class, we use extend to specify additional interfaces that this class is an extension of. Most everybody's happy. So what I'm saying is that this is a public interface. It's a contract for something called the stack of strings. Everything that implements stack of strings will implement these three methods. Stack of strings must implement these three methods. That's the idea of a contract. But this interface also extends a different interface. And you can extend many of them. It extends the iterable string interface. So in addition, anything that implements the stack of strings contract must also implement that contract, or those contracts. I can specify all of them. So if we now look at my implementation, Java will tell me that it's no longer valid because while my array stack of strings implement this interface. It doesn't executable interface. Find it. Array stack. And it's called after the right code. Basically, it will walk over the elements of the stack and each element, each state called. I'm going to, you guys are intelligent, you can handle it. Stack things for it's easy. Implement or extend it. Iterator is yet so there's one interface. What iterable and that and now iterate what data or interface iterate required. So here it is at the bottom. Next. Method called next one item, a method that sends back. Iterator represents a bit pointer that the user can use. And this pointer, I can ask the pointer, the iterator, and it will send back true or false in the connection. It has called next that the pointer is pointing to. I get the current element of the iterator, and they send back the data item. I'm actually iterating. And the last, so I can also which set up take the current instruction and throw it away and advance the point. This is haunting me. This is taunting me. It's not haunting me. It's taunting. This is also invalid. own password. Maybe my password has changed. Who knows? Never mind. Am I still on the internet? Yes, I am. Okay, so how much time do I have? Oh, we've got loads of time. We need to implement our iterator. Right. Okay. So I'm going to implement this thing and just screen. I'll just put in a few extra lines. But I actually hate doing that. I hate it when students add extra open lines to the code. This isn't paper. You don't have to leave open space for the code you're going to write later. Whenever you press return, there will be an open line. Okay, so don't do this. Don't do what I'm doing. I'm only doing it so you can see on the screen. Now, this iterator method must return a new instance of this interface, iterator. If I want to return a new instance of an interface, I need some kind of implementation. What kind of classes in Java already implement the iterator interface? What kind of classes are available as an implementation of the iterator interface that I can instantiate here and send back? No. Maybe. I don't know. I'm pretty sure somewhere in Java there's an array iterator, which will work fine because I happen to want to iterate over an array. But in general, you can't rely on the fact that there's already an iterator class that does what you want it to do. So you just have to write it, suck it up and write your own. And that's what we are going to do today. New iterator over string. Press Control space and create new object. Okay? Oh, no, that's not what I wanted to do. It doesn't look at all. Oh, I want to have no, not exactly what I want. Yeah, there we go. There we go. This will work. A new instance of iterator, and Java is going to complain that this is a interface. You can't create an instance of a class. But fourth new concept you have to learn today is to create classes, anonymous classes in line. You don't need the public class at the start of the class definition. You can, when you create a new instance of something, you can specify what that something must be and how it must behave on the spot. I almost bit my tongue. I'm so excited. Okay, so I think Eclipse. No, well. Exactly. So I asked Java. I don't know how I did this. I mean, this is Eclipse. Funny thing, it's not nothing with Java. I wrote return new iter, and because it's an interface, not a class. So I just put an open brace and a closed brace at the end. And now, inside these braces, I can fill in the implementation of the iterator interface. And conveniently, Eclipse for me. But if it didn't, I had to do that myself, of course. So, how will this instance of an iterator work? It will have its own private variable, that's the pointer, the actual pointer, and it's going to point to an index of in the array. We're going to start at the start of the array, so I'm going to have something I'm going to call private index. That's going to start at 0. So this is called index variable field. It's an instance field. So every instance I create has its own little index, and it's pointing to the next element of my array. Now, how do I know there is a next element? Because if the array is empty, the stack is empty, then index is pointing at 0, but there's nothing really there. It's an empty stack. And if the stack can hold 10 items, but there are only the stack, I've pushed 3 times, then I can't go past index 2 really. But luckily, this big class is telling me, it's counting the number of items in my stack. And this is an inner class inside this class. So I can see all the variables inside this bigger class. So I'm going to say there is a next one if index is less than n. This is amazing. No reaction. Is this how you react in a big shock? It's like stunned silence. Oh, it's a lion coming. Or oh, a car bomb. I want you guys to be screaming and shouting and ducking and things like that. This is amazing. I'm talking about this little index field that didn't exist before. I'm creating it on the spot to implement this iterated interface. It's a field called index. And I'm also referencing a field in the containing class. And I'm saying that if the current index that I want to return, that I'm pointing at, is less than n, then there is still the next element. If n is 0, then obviously 0 is not less than 0. So it'll be false. N is 0, nothing in the stack, index is 0, there's no next element. But if, for example, n is 1, then 0 is less than 1, meaning that I'm pointing to 0, index is 0, but n is 1, so that there is that one item at slot 0 of the arrow that I can send back. So that's has next, and next I'm supposed to send back a string. Okay, so I'll send back a string that I'm pointing to, but I must also remember to advance my index. Index must move to the next slot, but that's easy peasy. I'm going to write return. What's the array called? Items. Return item index, but also do a post increment of index. So I hope you learned well enough what this means. It means that I'm going to send back items index, and then as an afterthought, I'm also going to add 1 to index in a post increment. Okay. Everybody happy with this? I'm happy. I'm really excited. Will it work? Probably not. Let's face it, I'm not a genius. It's probably won't work. Oh, but this has gone away. So I've come on, Eclipse, work with me. Okay, I have changed stack of strings interface so that it also extends the iterable interface. It extends iterable, meaning that any implementation of stack of strings must implement iterable over strings. That meant I had to change my array stack of strings because it's now missing the iterator method. I had to add the iterator method, and to do that, I had to implement or send back an instance of interface iterator over string. And because I didn't have an implementation of that handy, I just created one inline. I've already explained the brilliance of my coding there. So let's just go to stack of strings. Everything should be in place. What do we expect this code to do? We push A, B, C, D. So A, B, C, D. D is at the top. And before just pop the stack. So B, D, pop, C, E, D, C, B, A. Okay, cool. Got the notes right. That's important. Okay, but now I'll go with the stack. Where do I start? I start at position 0, which is the first thing I put in the stack. So I expect this piece of code to start at the start again. So I'm pushing A, B, C, D. Iterator goes A, B, C, D on the screen. Then popping goes B, C, B, A, also on the string. So on the string, you want to see A, B, C, D, B, C, B, A. Now, Ricardo will pass around a hack where you can put in the money you're getting. I made a subtle mistake. Not subtle. A subtle mistake to trick you into learning something new, or is it working perfectly? So Chicago doesn't have a hat, we'll just vote. Working perfectly. What? How dare you? I'm insulted. Not working. Subtle mistake. Oh, come on. Too stupid to vote. I'm voting for Trump. Voting for Trump? Watch this space. Watch this space, and you guys, you watch this space. Okay? Oh. Yeah. Never mind, there's still mistakes in the linked list because they don't implement iterator. Oh. Oh. That doesn't count. Oh no, now there's a mistake. Fine, fine, fine. Now I'm going to do it for real. Okay, now this time it'll work. So, first 4 lines is because I was iterating. And my iterator started at the first item in the array, which is the oldest, and it walked through until it got to the last one. But not the last of the array, only the nth one, because n is counting how many items are in my stack. These last 4 lines is because I'm popping, so I get them in the reverse order that I push them. Last in, first out. D was last into the stack, so it's the first out of the stack, and that's why I'm printing on the screen first. Is everybody happy about this? Okay, now let's just for fun do an iterator that actually walks through the stack in the reverse order. So it starts at the freshest item in the stack and goes back. So I'll have to change my iterator a little. What is the first say that? Well, I started at 0 and went up to n minus 1. This time I'm going to start at n minus 1. I'm going to say, well, index is still greater than or equal to 0, because if index is at 0, that's still an item. And I'm going to do a pre-post decrement. And now we want to see BD, no, DCBA, DCBA. Just to make sure we understand what's going on. Yeah, that's fine. DCBA, DCBA. Okay, so I think everybody's happy. You feel that you've got your money's worth. How much time do we have? 10 minutes. Oh, that's a lot. More than I thought. Okay, I'm just going to change this back. I like it that way more. Okay, right. Let's see what else. So let's see what the book says. Interval collection. As mentioned earlier, one of the relations on A's and link. To introduce the concept, we start with a snippet of client code. Yeah, we did that for each statement, which you claim you haven't seen before. I'm convinced you have. Used on a daily basis. We could hardly imagine the code that is more clear and compact. Very true. I mean, it'll be difficult to write it's clearer than that. Do you think this code could be any do that short? You see, answer. Say again.
Remove the balls from collection.
Yeah, I can make the, but I'll still be stuck with 4 strings C. Send it out the print line. Even phone. Therefore, we embrace the latest password. Let's see. Let's see if I can get to the internet, because I want to show you something. I'm happy because I'm broadcasting. Yes, I am. This is really odd. What do you mean lock? In infinite number of attempts. What are you chatting about? Okay. Oh, I can't show you an example because I don't have a little example here. Do you think Wikipedia is open for the... Let's have... Oh, no! No, 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 no. No, 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 not this. I don't want to container shipping. Don't be ridiculous. API programming language. Here we go. So let's look at a few. Now, you remember that you've been taught Java, and in the second year we got C and cellular. And after that, you're on your own. So you also be taught Python. We expect you to learn any language in 2 weeks because you can program by then, and it's just a mapping of the concepts. So let's have a little look at APL and see how long it'll take us to learn to write a simple program. Let's find a little program. Can't see any programs here. In fact, I can't see any pictures either. Oh, it's still loading. Okay. Here we go. A few programs. Okay. Here we go. Here's a little APL program. Just enlarge a little bit. Just give me a second. There we go. So here's an APL program, open bracket, tilde, R, but, R, whatever, but. What does it do? It prints all the prime numbers from 1 to R. Okay, that's fine. Let's see if we can find something else. It's a little more exciting. Sorting. You implemented sorting. You know about sorting. Here's the APL program that sorts. So in APL, everything that you know in Java is reduced to 1 character. So for is the whole for loop is like 1 character. And this isn't just like for fun. This is a serious programming language that they used in the 60s and the 70s, invented by someone called Iverson. I can't recall his name. But the bottom line is that this is impossible to read. Once you've written it once, you'll never be able to read it again. Unless you're a big APL guru, this is a horrible programming language. You won't be able to learn it. We won't be able to teach it. And life. Oh, look, here's a little operation that removes all the tags in an HTML piece of text. So, bottom line is that we don't necessarily want absolutely as compact as possible, but really and just start array over the whole array. So use iterators code before Java. Just used to say things like there was no such iterations. And iterator build. If I iterator, I had to call iterator. Well, I can't call it, but I have to call it explicitly. And then I have to explicitly call while I has the next element, get the next element and put it in S. Write this code explicitly. And now